Can I get somebody to look up the dates for me on the date chart in your book on page 396, I believe? June 28th is what day? 179. July 29th is 210. September 2nd, 245, and October 4th, 277. So we have all of our days. So let's start out with our first action here. It's going to be on July 29th. Pat pays $2,500. So our first step is to figure out the days. So July 29th is 210. We're just going to subtract 179, which is 31 days. So our interest, $8,000 times 0.078 times 31 over 360. Always use ordinary unless you're told otherwise. Did you get $53.73 in interest? Perfect. So we add that back on. We have $8,053.73. We shall subtract the $2,500 payment. We are at $5,553.73. That's our balance after that payment. So our next action is on September 2nd. So we'll figure out our days again. September 2nd is 245. Minus July 29th was 210. That is 35 days. Notice I did not go back to the beginning. I only went back to the last point where we calculated interest. So our interest is our balance of $5,553.73 times 0.078 times 35 over 360. $42.12 in interest. We add that on. $5,595.85 is our balance before the payment. That was a payment of $2,200. So we are left with a balance of $3,395.85 after the second payment. The next action is on October 4th, day 277. Pat pays what, $1,300, I believe. So our days, we've got 277 minus 245. We've got 32 days. So our interest, $3,395.85 times 0.078 times 32 over 360. $23.54. So we've got to add that on. So $3,419.39 is our balance before the payment. We make the payment of $1,300. So $2,119.39 is our balance after that payment. That is our last action until maturity. To find our days, we have 120 days total, minus 32, 35, and 31. There's just 22 days left, correct? So our interest is going to be that balance of $2,119.39 times 0.078 times 22 over 360. $10.10. This $2,129.49 is the balance due at maturity. Total interest, add them all up, it's going to be $129.49. How many of you had that? Bless you. How many of you would have got to there except I cut you short of time? Okay. Those are long problems. I will give you that.
They're long.
They keep you sharp. There you go. That's not a bad plan. So when you hit the quiz, you've just done it. Cool. Well, what we've been talking about there is what we call simple interest-bearing notes. And like we pointed out last week, the face value on a simple interest-bearing note is the principal, which is what you start with. And to that principal, you add the interest that gives you the maturity value. The other side of that coin is something called a simple discount note. And a simple discount note, the word discount implies the price has been reduced. So you're getting it at less than full value. And that's exactly how it works. So you're paying a discount. You're paying less than what it's worth. But at the end, you pay back the full value. So basically, your interest is taken out before you get the money. So in a simple discount note, your face value is the amount you're going to pay back at the end. So what happens is you take your principal and you subtract, you have a discount, I should make this the other way around. You have your principal, which is your face value. And from that, excuse me, you subtract a discount. That is your interest. And that gives you the proceeds, which is the money you actually get. So that proceeds is what you actually get. To that, you would add back in the interest to get what you pay back. The discount is your interest. So up here, if it is a $10,000 note, they give you $10,000. You add interest to that, and then when you get done, you pay back more than $10,000. $10,000 plus interest. Down here, if it is a $10,000 face value note, they figure out the interest and subtract it out. What they give you is less than $10,000. And at the end, you pay back $10,000. So let's compare apples to apples here. Simple interest-bearing note, simple discount note. Both of these are going to be 10% for 120 days, $10,000. Well, over here, simple interest note is just what we've been doing. You receive $10,000 at the beginning. Your interest, $10,000 times 0.10 times 120 over 360. $333.33, correct? So that's your interest. Which means you pay back $10,000 plus the $333.33. So $10,333.33 is what you pay back. On the other side, the first thing you have to find is the interest. It's called the discount. Works the exact same as the interest over here. 10,000 times 10%, 0.10, times 120 over 360 is $333.33. So that means you find, then the second thing you find is the proceeds. Which is 10,000 minus the discount. Which means we get $9,666.67. That's the amount you receive. So on a $10,000 loan, you only get $9,666.67. How much are you going to pay back? $10,000. Very good. So you notice, both cases, $10,000 loan. Both cases, the interest rate, or the interest, dollar amount of interest comes out to be $333.33. The difference is here, you receive the full $10,000 and you pay it back plus the interest. Over here, you receive a discounted amount. In other words, they take out the interest first, and then you just pay back the full $10,000. Which situation would you rather have if you were borrowing money? You don't sound really sure. Well, the second one you pay back less. But in both cases, you're paying $333.33 in interest. Over. That's just it. Over here, you actually get the full $10,000 to use. Over here, you only get $966.67. You're paying the same amount of interest to use less money. There are a lot of cases where they require you to do it the other way. The effective interest rate is higher with a simple discount note. Because you pay the same amount of interest, but you get to use less of the money. So banks love discount notes. Now, as we pointed out last week, one of the biggest applications of discount notes from your side as an investor is something called Treasury Bonds. Let's say you're going to buy $500 Treasury bond at 4% interest for 10 years. The way it works is they figure out your discount, which is just the interest. So it's 500 times 0.10. I'm sorry, not 0.10, 0.04, I should say. Times 10. Which comes out to be what? Is that 200? $200. Which means, so that is your discount. Which means your proceeds are the full 500 minus the discount, which is $300. So this is your face value minus your discount. Gives you the proceeds. So what that means is you pay $300 right now for that $500 bond. And in 10 years, you can redeem it for $500. What if you keep it past that 10 years? Most of them convert to a flat interest rate after that, non-discounted interest rate. So if you keep it past 10 years, it's not like it's never going to go above $500. It will go above $500 in value, but it's a much reduced rate. It'll keep growing, yes. But it's a lot slower, lower rate. Yeah. Yes.
Wouldn't that just be basically the bank would be looking to use your money for 10 years, and obviously if they invested at a higher level than what they're paying you, this just gives them the option to use it for 10 years.
Exactly. And most treasury bills are actually government bonds, savings bonds, U.S. savings bonds. So the government is actually getting $500 from you to use for 10 years, and we're actually getting $300 from you to use for 10 years, and we'll give you back $500 at the end of 10 years. That's exactly what it is. Corporate bonds work the same way. They will issue a bond. They'll issue a $100,000 bond. They'll sell it for $80,000 or whatever. So it's a $20,000 discount. At the end of the period of time, you redeem it for the full $100,000. You can borrow money this way as well. As I said, usually it's if there's an anticipated amount of money in your future, you're going to borrow towards that amount of money. But we'll look at that example a little bit. Let's say that you borrow $7,000 on a 6% 90-day simple discount note. Find the discount to the proceeds, and 3, the maturity value. Maybe give that a shot in your notes. See what you come up with. So one part of this question I asked just to see if you're paying attention. Can anybody see what part that is? Maturity value. What's the maturity value? $7,000. On a simple discount note, the face value is the maturity value. You will pay back $7,000 at the end of this note. So, first step to calculate is the discount. So our interest is going to be 7,000 times 0.06 times 90 over 360. What's that? $105. That is our discount. So that's the discount. Proceeds. $7,000 minus 105 is $6,895. That is the proceeds. So in this loan, you would receive $6,895. You'll pay $105 in interest, so that at the end you pay back the $7,000. Does that make sense? Now, as I mentioned, typically this is used when there's a sum of money that you know is coming in a little while. For a company, it might be on what, for those of you who have any accounting classes, it might be on an accounts receivable. Let's say the invoicing we talked about. I made a sale on the 210 net 30. And so I have someone who has 30 days to pay. Their bill that has a balance of $3,800. I need that money right now. So I can go to the bank and borrow against that. Now there's two ways that this happens. One, I'm just going to borrow using that as collateral. Now if I'm using that as collateral, the bank doesn't want to give me $3,800 because at the end of the month I'm going to owe them more than $3,800. They're only going to give me the amount that they think I can pay back based on that collateral. So they're going to discount it. That's why they would use a discount note, because they don't want the balance to ever go above the value of the collateral. So they're going to discount this, finding the discount of my interest. Let's say they're going to give it me this for 8% charge. So it's going to be $3,800 times 0.08 times 30 days, so 30 over 360. So we get, what, $25.33? Is that what you guys got? Yes? Okay. That is the discount. So that means our proceeds $3,800 minus the $25.33. $3,774.67. So that's the amount of money we'll actually receive. So in order to collect that $3,800 30 days early, it costs us $25.33. Does that make sense? Yes.
So are you gonna like throw in the mixed payments this day, mixed payments that day?
Not with simple discount notes. For simple discount, that's very difficult to do. Yeah, you haven't made me that mad yet. Okay. Now we've mentioned, however, we're paying interest on the full $3,800 because the discount is calculated off the full $3,800. But we only receive that discounted amount. We mentioned earlier the effective interest rate is higher than what the 8%. So let's take a look at finding that effective interest rate. Well, we're going to still use our simple interest formula. I equals principal times rate times time. The difference is what we're going to put in here is going to be the amount of the discount. Instead of putting in the principal or the face value, we're going to put in the actual proceeds times our rate times our time. So for this particular note right up here, the amount of the discount was $25.33. The amount of the proceeds was $3,774.67. The rate is what we are looking for. Our time was 30 days, 30 out of 360. Now I should note, this process for finding an effective rate is going to be used here for simple discount notes. It will be used again next week for compound interest, for future and present value compound interest for effective rates. So this is a very important formula. And all it is just an application of our simple interest formula. So now here, I do have to combine on the right side here. Now remember where we said we're going to keep it in our calculator? Here's the spot where it's important. This is going to get ugly. You don't want to be writing this down and having to type it back in, or there's going to be severe round-off errors. So 3,774.67 is our proceeds times 30 over 360. Gives us a really ugly decimal. $314.555833333333333. I'm going to write down a number here, but I'm going to keep it in my calculator. So 314.56. Just so I have something written down. If I were to type that back in like that, though, I'm going to get a very rounded answer. It's going to be far enough off that my math lab would not accept it. Yes. I'll show you here in a minute. Well, but technically it's not. It's a rounded answer. So if I round here, or if I don't round, I'm going to do the 25.33 divided by the numbers being stored in my calculator. So 25.33 divided by, and then I'm going to go second answer. It equals, I'm going to get 0.080526. That is my rate. Divided it by this number, but I used what was in my calculator, so I did second answer.
Okay.
I'm going to come back to actually typing in that number in just a second. Now, if I convert this by moving the decimal point to make it a percent, that is 8.0526%. And now we can round it, however. I always go at least 5 decimal places on this rate, because generally we're going to round to either the 10th or the 100th of a percent. So that makes sure we get at least 1 digit past where we're going to round, so we know how to round it. Now, what if I just punched the numbers in? What if I just punched in 25.33 divided by 314.56? Not too far off. It's not too far off. 0.080525. When we moved it over, 8.0525%. Chances are on this one, you'd be rounding, like I said, either a 10th or a 100th. If you rounded to the 100th of a percent, both of them come out to 8.05%. So this is one where it wouldn't bite you. But it's also still easier just to use that answer key on your calculator to divide to. Sorry. Well, from this point in the class on, by the way, the last 3 homework assignments and quizzes, there are going to be round-off issues. Because when we get into compound interest, actually the last 4, we get into compound interest and we get into annuity calculations, there are tables you can use, and then there are formulas you can use. I prefer the formulas. You guys are welcome to use the tables if you want. But I think it's easier to use the formula than to use the table. Partly because I can memorize formulas and keep them with me, and I'm not going to have tables in my back pocket every time I need to calculate something. But with cell phones now, I do have a calculator on me all the time. That's not near as geeky of a statement as it was 10 years ago. 10 years ago, if you said you had a calculator on all the time, people, yeah, you math geek. But, so anyway. I suppose you can have them downloaded on your cell phone. Yeah, that's true. There's an app for that, I'm sure. But anyway, they're more accurate as well, because all these round-off errors we've been talking about, well, when they create the tables, they got to round the numbers to make them fit in the tables. So there's round-off errors there too. MathLab wants the tables. But if you use the formula, you'll know, because you'll be just, a few cents off, or sometimes in the bigger numbers, a couple dollars off. And if that's the case, just tell me and I'll go back in and fix it. These last 3 or 4 quizzes, I generally have to regrade them manually, so just let me know if it marks some wrong and I'll go back in and change them. Okay, so let's do another example of that effective rate. So Tim is at it again. Tim borrows $12,000 at 11% for 180 days on a simple discount note. Find the effective rate. Well, it seems like we're asking a simple question there, find the effective rate, but we still got to figure out everything else in order to get there. Remember, to do the effective rate, we need to know the amount of the discount. Discount's going to be our interest, which is $12,000 times 0.11 for 11%, times 180 over 360. Which is what, $660? Okay, so that's our discount. How do we find our proceeds? Here, 12,000. We subtract our discount of 660. 11,340 is our proceeds. Any questions so far? Okay. Now we are ready to approach the effective rate. What goes first here? Yeah, I equals PRT, but we're going to use the discount for the interest, which is 660. What goes in for P? Proceeds, 11,340. We are looking for R times 180 over 360. Now here's one where you don't have to worry about the answer key because it should work out relatively cleanly. It should be $5,670. And when I multiply the 11,340 times the 180 over 360. Yeah? Okay. So now I can divide by 5670. Give us 0.116402. Is my rate, which, if I move my decimal point, 11.6402%. If I wanted it to the nearest hundredth percent, that would be tenths, hundredths, 11.64%. How are you feeling about that one? Like you want to try one on your own? Chris borrows. Yeah, they're nice and easy, short. Chris, Pat, Tim, Pat, Tom. They're just nice and short and easy to write. Somewhat universal. That's part of the mystery. So Chris borrows $8,500 at 7.2% for 120 days on a simple discount note. Find the effective rate. Bless you. So our first step is to find the discount. $8,500 times 0.072 times 120 over 360. $204. Great. So that's our discount. Proceeds are going to be found by subtracting that from our 8,500. $8,296 is our proceeds. Effective rate. $204 is 8,296 times R times 120 over 360. So we start out combining 8,296 times 120 divided by 360. So we're going to get that continuing decimal again. So I'm going to keep that in the calculator. 2765. So that's 2765.33333. Now, to finish it off, I'm going to divide by that. So I have 204 divided by the previous answer. 0.073770. So I move my decimal point over 2 spots. That is 7.3770%. To the nearest hundredth. 7.38%. How many of you had that? Good deal. Let's go ahead and take our break. We're a little late. We'll start lecturing at 6:33.